Have you ever pushed a door open? Or maybe you have dropped an apple and watched it fall to the ground. These simple moments are full of cosmic secrets. They show us something that is everywhere in our universe. This special something is called a force. A force is simply a push or a pull on an object. It is the invisible hand that makes things move, change direction, or even stay completely still. Without forces, nothing would ever happen. The universe would be a very quiet and very boring place. Every single action, from the smallest breath you take to the biggest star exploding in the night sky, is governed by these fundamental interactions. Understanding forces is like finding a secret map to the universe. Our journey to understand forces began a long time ago. It didn't start in a fancy laboratory with big machines. It started with people just like you, looking at the world and asking simple questions. One of the first great thinkers to really explore this was a man named Isaac Newton. He famously watched an apple fall from a tree. He didn't just see a piece of fruit falling, he saw a cosmic mystery. He wondered why the apple fell down and not sideways, or even up. This simple observation led him to a giant idea, the force of gravity. He realized the same force pulling the apple also holds the moon in the sky. Newton gave us the tools to describe how things move and interact. Later, people like Michael Faraday probed electricity and magnetism. He moved a magnet near a coil of wire and made an electric current. It showed that electricity and magnetism were two sides of the same coin, electromagnetism. Then we looked inside atoms. Rutherford found a tiny, dense center, the nucleus. To hold it together required an incredibly powerful force, the strong nuclear force. So, after all that searching, we have found 4 fundamental forces. These are the 4 big rules that the universe plays by. Think of them as the managers of everything that happens. Gravity, electromagnetism, the strong nuclear force, the weak nuclear force. First, there is gravity. This is the one we know best. Gravity is the attraction between objects with mass, stronger for more massive things. It is weak, yet acts across incredible distances. It keeps you on Earth, keeps Earth circling the sun, and pulls gas and dust into stars and galaxies, the great sculptor of the cosmos. Next up is electromagnetism, responsible for electricity, for magnetism. It can both push and pull. It binds electrons to nuclei, holds atoms together, and makes light. Radio waves, visible light, microwaves, all electromagnetic. The solidity you feel and the glow of your screen exist thanks to this powerful force. Now meet the strong nuclear force, the most powerful of all. It overcomes electromagnetic repulsion and binds the nucleus. First, let's think about gravity. You toss a ball up. It rises, curves, and returns, a perfect demonstration of gravity. Earth is pulling on the ball, on you, your friend, and everything else on the planet. That gentle tug gives weight and ensures what goes up must eventually come down. Go to your refrigerator and stick a magnet on the door. That click is electromagnetism. Turn on a light. Electrons flow and the bulb glows. The light you see is an electromagnetic wave. Even touch is electron clouds repelling. You are feeling a force field. The strong force powers the sun by fusing nuclei, releasing light and heat. That sunshine on your face is the strong force's handiwork. A tiny fraction of potassium in a banana is radioactive. When it decays, the weak force changes a neutron into a proton. You can't see or feel it, but it's there, a subtle reminder of the weak force at work. The 4 forces don't just work alone. They work together in a beautiful cosmic dance, supporting and competing to build the universe. Think of them as a team of builders. From galaxies to stars to living cells, their interplay lets complexity emerge from simple rules. On the largest scales, gravity is the master architect, pulling vast clouds together. As clouds heat and ionize, electromagnetism pushes outward. It's a cosmic tug of war. Gravity pulls in, electromagnetism pushes out. When gravity wins, fusion ignites. The strong force binds nuclei. The weak force helps transform elements. Energy pushes outward as electromagnetic pressure, balancing gravity's inward crush for billions of years. Electromagnetism holds your atoms together. Gravity anchors you. The strong keeps nuclei intact. The weak helped forge heavy elements that became you. You don't need a laboratory to feel a fundamental force. Try to stick it to a wall. It will just fall. Gravity is pulling it down. Now rub the balloon on your hair or a wool sweater for 10 to 15 seconds. Tiny electrons move onto the balloon, making it negatively charged. Your hair becomes slightly positive and is attracted to the balloon. Near a wall, the balloon repels wall electrons, leaving the surface slightly positive. Place the balloon. Let go. It sticks. You just used electromagnetism to overcome gravity. A balloon and a bit of energy. That's all it took. From a simple push on a door to the glue holding galaxies together, we've toured the four forces. Gravity pulls. Electromagnetism shapes light and matter. The strong binds and powers stars. The weak transforms particles. These forces aren't distant ideas. They are partners in our lives, connecting us to the cosmos. The iron in your blood was forged in exploding stars by these four working together.